Hello and welcome back to Steam It with Steve. Today we're going to keep going with the Python coding batch tutorials and we're going to finish them off with list number 2. So let's jump on in. Here we go. So here's the coding batch. We're going to go down to list number 2, which is our last one. And we've got 6 different things that we're going to try and punch out today. So we're going to do count evens to start with. So let's open this guy up here. So to start, return a number of even ints in a given array. Note that the %mod operator computes the remainder. For example, 5 mod 2 is equal to 1. So literally it's going to be counting all the even and odd numbers. So if we start at the beginning, 0 mod 2 is 0, 1 mod 2 is 1, 2 mod 2 is 0, 3 mod 2 is 1, 4 mod 2 is 0, 5 mod 2 is 1, 6 mod 2 is 0. So what you should see, all the even numbers are 0 and then all the odd numbers are 1, and then they alternate between the two of them. So we need to have a variable to store how many we count. So we're going to go count is equal to 0, and we're going to iterate through this. So we're going to go for x in nums, right? And then if x mod 2 is equal to 0, then, so snaky by it, count plus equal to 1. And then at the end here, we return the count. Let's run that and see what happens. Cool, all correct. And then there's a little hint here. Yep, so they just did the same. So they said for num in nums, which means going through each of the array elements and storing it in a temporary variable called x. And we'll loop through and do it that way. Cool. Next one, big difference. Given an array length 1 or more of ints, return the difference between the largest and the smallest value in the array. Use the built-in min and max functions to return the small and the larger of 2. All right, so to initiate these, we're going to make 2 variables. I'm going to call them smallest, which is going to go from the very beginning, and then the largest, which is going to also go from the very beginning. So then that means that those variables exist and they at least have a value. It might not necessarily be the value that is the smallest or the largest, but at least they're initiated. We're then going to use the same function that we just did. So we're going to go for x in nums, then we're now going to reset what the largest and the smallest is. So the smallest now is going to equal to the minimum. So the minimum between what the current smallest is and what the value of x is currently at. So what this will do, it will look at what's currently stored as the smallest and then what's currently stored in as x. Right, so it will be a bit redundant the first time around. It will just look at zeroing the position 0 and position 0. But then when it gets to the next one, when it looks at 3, it's going to go, yep, 3 between 10 and 3, which one's smallest? It's 3, dump that in. Then it's going to go, which one's smallest, 3 or 5? Stay with the 3, so smallest would stay. And then we'd look at between 3 and 6, which one's the smallest? It would stay with the 3. So then by the end, it should spit out 3. Then we're going to do the same process for the largest. So the largest is equal to the max between the largest and x. And that's going to do exactly the same process. So once that loop's finished and it's gone through every single element, we'll have the smallest and the largest. So the last bit then is we need to return the difference between the largest and the smallest. So we just literally do that. Return the largest minus the smallest. Run that. Nums there. Awesome. Next one, here we go. Centered average. So return the centered average of an array of ints, which we'll say is the mean average of the values, except ignoring the largest and the small. So that sounds like we've got to use what we did before. If there are multiple copies of the smallest value, we just return 1 copy. Likewise for the largest value. Use int division to produce the final average. You may assume the array length 3 or more. Cool, so there's definitely going to be 3 elements, and at the end we're going to take away the largest and the smallest. So let's do it again. We initiate them, so we'll go with the smallest first. So smallest is equal to nums over there at 0. Then largest is equal to nums at 0. Then we're going to go for it. So for x in nums, snaky bite. And then we'll do the same process. So smallest is equal to the minimum between the smallest and x. And then the largest is equal to the max between what currently is the largest and x. We then also want to sum, so we need to add all these things together. So we're going to go make another variable, sum is equal to 0. And then down here inside of the loop, we go sum plus equal to 0. So then at the end of this, we then want to return what the value is. So we're going to return the sum, and then we're going to take mean average of the values except ignoring the largest and the smallest. So we're going to take away the largest, and then we're going to take away the smallest, like they just told us to do. Then when we divide this, so let's say that there was, in this case, there was 5 numbers. So there was 1, 2, 3, 4, 10, 100. The largest in this would be the 1 and the 100. So you would only be finding the average of these 3 numbers. So even though there was 5 numbers, you'd be only finding the average of 3. So when we divide it, so we use interdivision, which is 2 forward slashes. We're then going to find the length of nums. And then we're going to subtract 2 from that, because then it's going to take away the largest and the smallest values from how many we're dividing it by. We're then just going to wrap that up in brackets. There's no harm ever using an overkill in brackets, because that then protects the order of operations. So this will definitely do the smallest, the sum minus the largest minus the smallest first. And this will definitely do the length of the nums minus 2. And then it would do the integer divide. So let's see what happens there. No, what have I done? So 34 came out and it was meant to be 3. That's curious. Okay, so it's got 34, so it's kept the largest somehow in there. Ah, X. My bad. So we've added in, we forgot to add in X. There we go. Easy to do, happens to the best of us. Okay, so yeah, that was my bad. I forgot to put, I did sum plus equal to 0 instead of sum plus equal to what the current value is. Next one, sum 13. Return the sum of the numbers in the array. Return 0 for an empty array, except for the number 13 is very unlucky. So we do not count and numbers after that immediately. So the number straight after 13, we don't count it. Okay, so if it's greater 13, that number 13 and whatever numbers after it doesn't count. So 1, 2, 2, 1 just adds together, 1 and 1 adds together, 1, 2, 2, 1, 13 just adds the 1, 2, 2, 1. And if we had another element after it, we would skip that as well. So I think this, there's a bit of a logic here because we're skipping stuff. So I'm actually going to use a while loop here because it's a bit more logic based. So to do that, we're going to do a sum variable. We're going to make that equal to 0. We're then going to make a variable to control the loop. So we're going to make that equal to 0. And then while I is less than or equal to the length of nums, snaky bite, we're then going to do stuff. Now, the cool part with this is we can then increment stuff. And if it goes outside the bounds, it's not in a for loop where it's very rigid and it has to go across a certain amount each time. This structure allows us to play around with how much we increment depending on the value. So if the value at nums I is equal to a 13, what we can do now is we can actually skip everything. So what we can do is skip this one, don't do anything, so we don't add anything to the sum, and we just add on 2. So then what happens is, even though if it gets past the end of the list of numbers, the number will be greater than the length of nums, and then just will exit the loop. So then the other part to that, else if this is true, we then go sum is now plus equal to what the contents are in nums at X, and then we increment as normal. So then we just go I plus equal to 1. So this is what we normally have inside of a loop, plus 1. But this is, by using this structure, allows us to skip if there's a 13 inside of it. And then after it exits the loop, we then want to return the sum. Let's see how this one goes. X not defined. Oh, sorry, I, because I used I instead of X. That's my bad. Give that a whirl. Out of range. Okay. Let's have a look at it. Oh, not equal to, just less than. Cool. So it was my bad. If it's less than or equal, it will keep going past that. And then the array doesn't, because we always start at 0, we don't start as 1. So that's why that works. Cool. Next one, sum 67. Return the sum of numbers in an array, except ignoring sections of numbers starting with a 6 and extending through to the next 7. Every 6 will be followed at least by 1 7, so it's going to be a pair. So it changes 6s, then changes to 7, ignores everything in here. So 1 2 2, that just adds to 5. 1 2 2 6 9 9 9 7. The 99s get removed. And 1 1 6 7 2. 1 plus 1 plus 2 gives you 4. So whenever there's a 6, it's almost like you can't do anything with it. So what we're going to do is we're going to make a check flag. So we're going to go check is equal to true. All right. And then we're going to do a sum variable. So we're going to go sum is equal to 0. Now this check flag is going to basically go on and off. So it's just like a little postbox lever. So if a 6 happens, the lever goes down. Right. And then if a 7 happens, we can then pull it back up. So I'm going to do this again with a while loop. So while, and then make a variable up here to control the while loop. So while, make I is equal to 0. So while I is less than the length of nums, snaky bite, and we'll check for the check first. So if, what do we want to do here? If the current value, so whatever we're looking at now, so nums at I is equal to a 6, snaky bite check is now equal to false. So then it just flags it all off. So we've got that done. If the check is true, snaky bite, we then add it on. So sum plus equal nums at I. So if it's true, just adds it in. And then lastly, we want to check if the number at I is equal to a 7. Check now equals true. So what the cool part with this is, basically if, say the first value is a 6, all good, it's a 6, it then goes, is this true? No, it's false. So skip it. Is it equal to 7? No, it's false. Go across. Oh, and then we need to increment as well, sorry. So down here we'll go I plus equal to 1. And then adds 1, goes to the next one, checks if it equals a 6, no. Checks it, no, false. And then let's say the next one's a 7, it goes no, no, then changes check to true, increments it, this is still true, this is now not a 6, but it's true. So then if this is true, it will add it on, and then it will keep going through that pattern. Let's see how this one goes. Nums, sorry. Give it a run. No, okay. I haven't returned the value at the end. And then return the sum. Cool. Done and dusted. Last one has 22. So we'll just do a for loop with this one because we just want to power through every single value. Not too complicated logic. So we're going to have, here we go. We're going to go 4x in range in nums. No, we want to do a range because we want to take away 1 at the end. So if we want to go 4x in range, the length of nums minus 1. Snaky bite. If nums at x is equal to 2 and nums at x plus 1 equals 2, snaky bite, we return true. Otherwise, we've gone through the whole thing and we just return a false. So let's see how that goes. Cool, done. Excellent. So that's pretty much all the CodingBat examples done and dusted for you. My hint to you is to practice these as much as you can. Like I tell my class, the first time you learnt your multiplying, 7 times 5 probably freaked you out. You're like, what do you mean 30, oh, 35? Yeah, I get it. And then eventually you start getting used to it because you use it more often. The more you practice this by going through and pressing pause and playing these videos through and trying to do it before I do it, the quicker you'll get at your CodingBat. okay, which will get you up to a pretty strong standard for a beginner's sort of starting into an intermediate level with Python. Practice, practice, practice. The more you can do that, the better you'll become. So thanks for watching. If you enjoyed, please give us a like and subscribe down the bottom, as it helps with our YouTube algorithm. And then, yeah, see you next time on STEAM with Steve. Adios.